And we're here to use our GDC to solve some kind of problems are we doing here?
Some word problem involving systems of equations.
Super! It makes me so happy when I hear things like that. So take a moment, read the question. It's really important that you understand what you're reading. And then, so pause it to listen to us. Or pause it to read. Oh, we should be back now. So we're going to go to Apple Orchard and pick apples this weekend. The owner charges $5 just to get into the orchard. Plus $2 for every pound of apples I pick. The grocery store charges $2.50 per pound. It's kind of like kilograms. How many pounds of apples would Johnny need to pick for the total cost of picking the apples to be less expensive than buying them at the grocery store?
Okay. So what are we looking for? What are the two unknowns in this question, in this problem?
Oh, I don't know how much it cost. I don't know what the C is, the cost factor, which is going to be in dollars. Cost, I don't know. I think also the other thing is how many pounds of apples.
Right.
So I'll call it P for pounds of apples. Does that work?
So P for pounds.
P for pounds.
Pounds of apple, and C for cost. And usually we can find the unknown quantity in the question asked. So since the question asks how many pounds of apple, we know that's one unknown. And then we also have to find the total cost. So that's the other unknown.
Right.
So since there are two unknowns, we know we have to set up two equations.
Okay.
So then we have to go back and read the problem and pick out two equations from the information given.
Well, I think this is the orchard. It tells me stuff about the orchard. So there's $5 to get in. So the cost, I know it costs me $5 just to walk onto the orchard.
Right.
But then for each apples I buy, I get 2 pounds. So it's going to be, add the cost, is going to be 2 times every pound that I get.
$2 per pound.
$2
and
per pound.
Johnny picked P pounds of apple.
Right.
So the total cost would be 2P plus 5 to enter the orchard.
Super. All right. And then,
now for the other equation, we have to write an equation to represent the cost buying apples at the grocery store.
Right. And there's no charge to walk in the grocery store. It just costs $2.50 per pound of apples. So the cost then is going to be just $2.5 per pound.
Right. So there's our system of equations.
Super.
And now we're going to solve it using our GDC.
You know what all they're going to want? They're going to want to do it by algebra. And if they do it by algebra with this command, they get nothing. Absolutely nothing.
We won't even look at it.
Right, because we're not asking you, do you know how to do it by algebra? We're asking you, do you know how to do it with this?
Right.
Not an option. So we're going to, in our calculator, we're going to pretend that this is really y is equal, go away, y is equal to 5 plus 2x. And y is equal to 2.5x. And we know that that's what we have. So I just type 5 plus 2x. Enter that. And y is equal to 2.5x.
Right.
Enter that. And then I'm going to zoom it to my standard window number 6.
Right.
There's the first line. There's the second line. Ooh.
What's wrong with this window? What do you expect to see?
I'm expecting to see a point of intersection, I thought. It's going to be up here somewhere.
Right.
So I want to go higher up here.
Right.
That's my y value. I want my y to be higher. So I'm going to go to my window.
And keep x. Or maybe should we change x min?
Ah, right, because pounds, I can't have negative pounds.
Right.
So let's make it 0. And then we'll do 10 pounds. My y min is, I can't have negative $10, so let's make that 0 as well. I know I want to go higher. Let's make it, I don't know, $50?
Sure.
And if I graph that, here's the first line, here's the second line.
Oh, almost. So okay, now what should we change? Should we change x or y in order to see the point of intersection?
So I want to go out this way here, so I want to go x.
Okay.
So change my x. And let's go out to 20 pounds of apples.
Okay.
We'll graph it. What a great graph this is. Here's my point of intersection.
Yep.
And so if I go to my calculate menu, the blue one, wherever it's blue, it means I have to hit second first. And I see the second command is up there. I go calculate, and I want to find the intersection number 5. And well, it's asking me a question. It's asking me first curve. Is that the first equation?
Yes.
So then I say enter by saying yes. Is this the second equation?
Yes.
Yes. And then it asks me for the guess. And
I don't want to guess.
I don't want to guess.
Yep.
I just think it's close to the answer.
Yep.
So I'm just going to hit enter.
Yep.
And it actually that's coincidence. It happened to be on there. And
Yep.
so I know that x, which is p, equals 10, and c is equal to 25.
Okay.
Okay? And so we should make a graphical solution here. So when I make a graphical solution, I want to make it about what I see in my calculator. Here, and maybe here. And this is my point 10, 25. This is, I should use C's and P's. C is equal to 2.5p, and C is equal to 5 plus 2p. And then what's the answer to my question? It says, how many pounds of apples would Johnny need to pick for the total cost of picking apples to be less expensive? The cost of being less expensive than buying them at the grocery store. So, well, this is the grocery store price, and this is the orchard price. The O, put an O here and a G so we can tell the difference. So, all these values here, this is when they're equal. All these Y values are lower. So, whenever I have 10 pounds or more, the orchard is cheaper.
So Johnny should go to pick his apples at the orchard if he's going to pick more than 10 pounds
Exactly.
of apples.
Nice.
So we want to make sure that we answer the question and not just find the intercept.
Right. Make sure you understand what's being asked.
Good.